Welcome to VMware vSphere 7 training from ESXi Lab. I'm your instructor, Larry Karnas, and in this mini course, what we're going to do is take a close look at the virtual hardware layer of virtual machines that we would build on an ESXi host. So what I want to do is show you how to build and size the virtual hardware layer of a virtual machine. And we're going to do that according to best practices. There's actually three parts to this course. Part one is the presentation that I'm doing now, and it's going to go through about 17 or 18 slides, and the idea is to fully explain what's going on at the virtual hardware layer of a VM. In step two, what I'm going to do is take you through a lab demo of a live ESXi host, where I'm going to show you how to launch the new virtual machine wizard and talk you through step by step as we build the hardware layer of our new virtual machine. So we're going to start with the new virtual machine. We're going to go through all of the steps in the wizard, discussing them in detail so that you understand exactly how a virtual machine's hardware layer is specified and how you can size it according to your needs, including how to size CPU, memory, storage, and how to specify any additional devices that you may wish to add to your VM. And the third part of this course is an optional free downloadable ebook that covers all the presentation material and how to actually build the virtual hardware layer of a virtual machine. Let's move on. So a virtual machine is a full machine in software. So what I mean by a full machine is when you normally think of a PC or a PC server or a notebook, you start by thinking about the hardware, the physical device, and then we think about the operating systems and applications and so on that we wish to put on the physical device. Well, a virtual machine is a full machine in software, and it supports modern, popular guest operating systems. The term guest operating system is just a term used for an operating system installed in a virtual machine. So we're going to take a look at virtual machines from the hardware layer. We're going to see what virtual hardware we get by default. We're going to see the CPU and memory layout of a virtual machine and how we can adjust it so that we size CPU resource availability and memory resource availability according to our needs. And you'll notice a convention that I'm following here. This is something that's widely used in the vSphere environment. A little V in front of a term means virtual. So virtual hardware, virtual CPUs, virtual memory, virtual NICs. And not surprisingly, a little P in front of the same word would mean physical hardware, physical CPUs, physical memory, physical NICs. We're also going to talk about other devices that I may wish to add, including CD-DVDs, floppies, USB devices, and so on. Now, anybody can just go in and build a virtual machine. I'm going to give you some sizing tips. How to make sure you have enough CPU, enough memory, enough storage, and so on, so that your VM is correctly sized for the anticipated workload that you expect to be running on your virtual machine. And I will also talk about best practices. Essentially, making decisions about which is the best hardware for me to use when there's multiple choices. We'll see it as we go. Now, before we actually get into building the virtual hardware layer of a virtual machine, what I need to do now is talk to you about the operating systems that I can actually install in an ESXi, or in fact, any VMware virtual machine. VMware only runs operating systems. So VMware only runs operating systems designed for x86, which is to say 32-bit, or x86 64, 64-bit Intel and AMD CPUs. So it cannot run or virtual machines for other CPUs like IBM's Power Series, HP's PA RISC, SunSpark, or anything like that. And the reason for that is because my PC server is powered by a high-end Intel or AMD 64-bit CPU, and 64-bit AMD and Intel CPUs have a common instruction set, and x86 or x86 64-bit operating systems were programmed to run on those CPUs and only those CPUs. Now, if you're a fan of Microsoft operating systems, you can run Windows Server going all the way back to Windows Server 2000, all the way up to Windows Server 2022. If you like to run desktops in your VMs, then you can start with XP, Service Pack 3, and then you can go to Windows Vista, Windows 7, Windows 8, Windows 10. It all works. Now, VMware will happily run legacy Microsoft operating systems like MS-DOS, Windows 3.x, Windows 9.x or ME, even Windows NT 3 or 4. They still work, but VMware ended guaranteed support as of vSphere 6.0, which went end of life a couple of years ago. So what this means is while these legacy Microsoft operating systems still work, VMware won't take support calls on them. So you'll have to self-support or community support on those. In other words, search it on the internet. Now, what also works is Linux. Business editions of Linux from SUSE, Red Hat, Ubuntu, Debian, and so on all work just fine in a virtual machine. And many of the other operating systems programmed for x86 or x86-64 also works. So Apple, for the longest time, was using Intel CPUs for Mac OS X. And so any version of Mac OS X that was designed and released to run on Intel CPUs should run in a virtual machine just fine. Likewise, Oracle, who now owns Solaris, had in the field versions of Solaris 10 and 11 that were specifically built and released to run on Intel and AMD powered CPUs. And there were 32-bit and 64-bit versions of these operating systems. Oracle has since stopped this practice, so you cannot get the latest, greatest versions of Solaris all programmed and ready to go on Intel or AMD CPUs, which is unfortunate, but they own the software, they do what they do. There is a family of Unix operating systems called BSD, Berkeley Software Distribution. There's the free distribution, the open or net. So it's FreeBSD, OpenBSD, NetBSD. These are different distributions of the base BSD operating system. They work great in a virtual machine. And there was a company called Santa Cruz Operation whose business was to supply Unix versions for Intel-powered hardware. They had a legacy version called Open Server and a more modern version called UNIXware. These machines are still found. They were popular in small to mid-sized business. The vendor has since gone out of business, so if you're responsible for keeping one of these machines alive, you can migrate it over to a virtual machine and virtual hardware will always just work. So let's take a look at the virtual hardware layer of a virtual machine. First of all, just like physical machines have physical hardware, virtual machines have virtual hardware. So what is virtual hardware? Virtual hardware is software that behaves in a manner that is indistinguishable from real hardware. So it looks, acts, and functions exactly like the real physical counterpart. So essentially, VMware engineers created software that behaves like a motherboard, a storage controller, a network controller, a video controller, a SATA controller, SCSI controllers, and so on, SCSI disks, and the like. Now, CPU and memory services are provided to the running virtual machine by the PC server that ESXi is installed on. So those compute resources are just handed by ESXi over to the VM whenever the VM needs to run. These components here are essentially software that look like a storage controller, software that look like a NIC. And this is software that looks, acts, and functions in a manner that is indistinguishable from real hardware. Now, the cool thing about this is your operating system, whatever you've installed into your VM, when it needs to do an I/O, it hands the I/O to the virtual hardware. The virtual hardware takes the I/O and basically hands it to the VM kernel, the core OS component of an ESXi host. The VM kernel will then complete the I/O on the appropriate backing physical hardware. It will take the success fail code received by the physical hardware, pass it to the virtual hardware, who will then pass the success fail code into the operating system, who will see that the I/O completed and report as much back to the guest OS and/or applications. So in other words, virtual hardware is essentially a layer that allows I/O events to flow from the VM to the VM kernel where they are completed, and then the results go back from the VM kernel to the virtual hardware to the guest OS, who sees that the I/O event completed. VMware's vHardware is designed to faithfully emulate the behavior of popular physical devices. And the reason why VMware picked popular physical devices is so that when you install a guest OS of your choice into your virtual machine, the guest OS will come with drivers. So these are drivers provided by Linux, provided by Microsoft, provided by Solaris, or whatever. And VMware carefully selected the virtual hardware for broad guest OS compatibility. In other words, the virtual hardware devices here will be identified and will work with drivers supplied by popular OS vendors. This eliminates install time driver headaches that you might have to deal with if, while you were installing a guest OS, you had to install a network controller and a SCSI controller driver and other drivers, a video card driver, and so on during the install process. So what this means is, for the most part, your virtual machine should work just fine as you install the OS. When you reboot and activate the OS should be able to identify all the virtual hardware, select the appropriate drivers from the guest OS's driver cache, initialize the driver and bind it to the virtual hardware, and then start doing I/Os through the virtual hardware, and your OS will continue to initialize, come up, and will be ready for service. Once your OS is ready for service, what you'll see is that applications that run on the same OS when you install the OS on a physical machine should run without an issue with the OS installed on a virtual machine. What I want to do now is take you through the wizard to build the new virtual hardware layer of a virtual machine. And so what I've already done to get to this screenshot is I've logged into my ESXi host and I've launched the new virtual machine pop-up. We can see what's going on in the first stage of the pop-up simply by zooming in a little bit. So let's do that. So what we see is that in step 1, I had to select the kind of operation I wanted to perform. I could build a new virtual machine from scratch. I could essentially register an existing virtual machine that's on storage that's visible to me, or I could import a virtual machine in something called OVF/OVA format. We'll talk about those things in another course, but what I want to do is talk about building a new virtual machine from scratch here. To do that, what I want to do is move on to step 2, and in step 2 here, what we're going to do is we're going to start to specify the basic properties of our new virtual machine. The virtual machine needs a name, and so we give it a name. I just called it Larry K Windows 10A because I have no imagination. The next thing is the compatibility. With every new version of ESXi, VMware extends the capabilities of virtual hardware. Newer versions of ESXi are able to build virtual machines that are faster, more scalable, can use more modern devices, and so on and so on. And because I'm demonstrating how to build a virtual machine on an ESXi 7.0 host, which is at the time of recording the latest greatest version of ESXi, I'm going to set compatibility to ESXi 7.0 because I want to take advantage of all those features, capabilities, scalability, and so on. If you had older versions of ESXi still in service in your production environment, what you would do is click this drop-down and pick the version of ESXi installed on the oldest machine in your production environment. And the reason for that is because older ESXi hosts do not know how to run virtual hardware that is configured for newer ESXi hosts. So an ESXi 6.5 host would not know what to do with a VM that declares ESXi 7.0 host capabilities. Whereas an ESXi 7.0 host can easily boot and run a virtual machine that declares ESXi 6.5 compatibility. If you have older ESXi hosts, always pick the oldest version of ESXi you still have in production. But in our case, we only have one ESXi host, it's ESXi 7, so that's what we're going to pick. The next thing I want to do is I want to pick the operating system family. And there's only 3 operating system families. There's Windows, there's Linux, and then there's everything else. And so what you see here is I've picked Windows because in a follow-up video, I'm going to show you how to install Windows 10 into a brand new virtual machine. So we're going to start with the OS family of Windows. Once we pick the OS family, the next thing to do is to click the OS version dropdown and specify the particular version of Windows we wish to install. Is it a Windows desktop? Is it Windows Server? Is it 32-bit? Is it 64-bit? Which edition is it? And you'll notice if you look up and down the list, you can see things like MS-DOS right here. It will literally let you build a virtual machine for legacy MS-DOS, which was an operating system popular in the late 1980s. So it still works. Here's Windows 3.1 down here. It still works. Okay, but in our case, we're not going to do any of that. We're going to just stick with what we've highlighted, which is Microsoft Windows 10 64-bit. Okay, now if you make a mistake, if you pick the wrong OS within the correct OS family, it's not a big deal. You can edit the virtual machine after you create it and correct that error. At the time that you create a virtual machine, what the OS family and the specific OS does is help pre-select virtual hardware that will work with the declared guest OS. So for example, if you were to pick, say, Legacy Windows Server 2003, you would get IDE CD-DVD readers. If you pick Windows Server 2019, you're going to get a SATA CD-DVD reader at the virtual hardware layer. Because in 2003, SATA didn't exist. And in 2019, you can't buy hardware with an IDE controller on it anymore. So VMware's new virtual machine wizard tries to pick hardware that will give you a good virtual hardware experience for the guest OS that you intend to install. So VMware creates new virtual hardware versions with most new versions of ESXi. And it turns out with ESXi 7.0, VMware released virtual hardware version 18. And again, VMware improves their virtual hardware to provide more scalability, better performance, support for newer hardware, just like physical server makers and desktop makers improve their motherboards for compatibility with the latest hardware, the latest devices for best scalability, and so on and so on. So with virtual hardware version 18, what we get is a set of virtual hardware devices that are appropriate for the OS that we intend to install. So here we are zoomed in. The core of the virtual machine is software that behaves like motherboard resources. So that's VMware's virtual motherboard that emulates a legacy Intel BX-DX-ZX chipset. A chipset is the additional logic on a motherboard that allows the CPU to interact with motherboard devices. So this would be timers, PCIe buses. And so what VMware does is faithfully emulates the behavior of a very popular physical chipset. Now what I'm going to do is I'm going to go around the clock. We're going to start at the keyboard and mouse. And I'm going to just talk briefly about the virtual hardware components that you'll see. You'll see a PS2 style keyboard and mouse. Again, it's software that emulates a keyboard. You'll see a video card. And in the video card, what you get is either a basic 2D or a 3D video card connected to a virtual console. Now, 2D is appropriate for server operating systems and any operating system that's not doing 3D graphics applications. 3D would be for, again, possibly server operating systems if you intend to install 3D aware applications in that operating system. So VMware does not distinguish anymore between server and desktop. In the old days, it used to be that only desktops could go 3D, servers had to stay 2D. But in the modern world, you can configure your video card to be 2D or 3D on a virtual machine with a desktop OS or a virtual machine with a server OS, doesn't matter. Next, what you get is IDE or SATA devices. IDE devices would be presented to legacy operating systems like Windows 7 and back to Windows Server 2003, Windows XP, that sort of thing, because in the old days, IDE was popular, and you could have up to one IDE controller with up to 4 IDE devices. In more modern operating systems, SATA is supported, so what I can have is SATA controllers with up to 30 SATA devices connected. Now, the most likely thing I'm going to connect to a SATA or IDE controller is a virtual CD-DVD device. And the reason I'm not going to connect a hard disk as a SATA device is because of performance. What I'll mention later on when we talk about storage controllers is it turns out that SCSI, or Small Computer Systems Interface controllers, are literally 3 times faster than SATA or IDE connected hard disks. Now, if I want, I can optionally have a floppy controller with up to 2 virtual floppy drives. Why would I want a floppy? Well, because driver media images are still released in FLP format. And so if I have to add custom drivers to make my virtual hardware work, I may have to have a virtual floppy so that I can read the media image for my virtual floppy driver. I can have a USB controller, and my USB controller can connect to up to 20 USB devices. I can have as little as 4 megabytes of RAM to as much as 24 terabytes of RAM, assuming my physical PC server can deliver that much RAM. Now, as far as CPUs go, I can have as little as 1 CPU core in my VM, or as many as 768 cores in my VM. And again, assuming that your physical server can deliver that many physical CPU resources to a VM. These maximums are maximums that VMware tests on ultra high-end PC server hardware. I mean hardware literally costing the price of a house or more. Most of us don't need or use that kind of hardware, and so we will have much more modest memory needs, much more modest CPU needs, and so on. So moving on to storage, what I can have is up to 4 storage controllers with up to 64 virtual disks per controller with up to 62 terabytes per disk. That gives me the capacity for an awful lot of storage. Okay, now I'm probably not going to need all of that, but my VMs can scale up if they have to. I can have up to 10 virtual NICs plugged into different LAN segments. I can have up to 4 virtual NVMe controllers, and those virtual NVMe controllers would connect to virtual NVMe disks. And as you can see, I can have up to 60 NVMe disks. So what I have over on the right is a more detailed roster of all of the components I can plug into the virtual hardware layer of a virtual machine that is using virtual hardware version 18. So this is appropriate for virtual hardware version 18. Now, I don't need all of that. As a matter of fact, I've never built a virtual machine with all of that. So what happens is, as I go through the new virtual hardware wizard, what I do is I specify additional properties that my virtual machine is going to need. So again, I'm going to zoom in. And so in step 3, I would select storage. So I would specify the virtual SCSI controller and the virtual disk. Essentially what will happen is it'll recommend a SCSI controller and a disk of a particular size for me, and I can override it if I want. So for example, I am currently in step 4, and in step 4, I can see that I have a hard disk, that it's pre-declared to be 16 gigabytes, and if I want, all I have to do is take the 16, click in the field, erase 16, and type in the size I want. Just type in the size I want. And it will make a disk as big as I need. So you'll notice I already have CPU declared. I get 1 CPU core. That means 1 core on a single socket. And if I want, I can click the drop down and I can have more cores and or more sockets as I see fit. Likewise, I can increase the amount of RAM. By default, I get 1 GB, which by today's standards isn't very much. And I can dial that up to as much memory as I think my VM will need. Now, not only do I get a hard disk here of a certain size, but I get a SCSI controller. And there's 3 SCSI controllers that I can choose from, and VMware defaults to the most efficient SCSI controller, the VMware Paravirtual. It turns out there's 2 legacy SCSI controllers that you can also choose from, but the Paravirtual in almost every case is your best choice. I can have a SATA controller. I get that by default so that I can connect to CD/DVD readers. I can have a USB controller. If I don't like it, I can just delete it. If my VM has no use for USB, I can just delete it. I get 1 NIC by default. And a NIC is a piece of virtual hardware that acts and functions like a network interface card or a network adapter. And it plugs into a port group, which is a named set of ports on a virtual switch. And so I can click this drop down and pick any pre-configured port group that exists on my ESXi host, because I may have different port groups that uplink to different LAN segments like production. There may be internal LAN segments, meaning that they can't get out onto the internet, that sort of thing. There may be a management LAN segment, a storage LAN segment, and I can plug my VM into any one of those LAN segments. And here's my CD/DVD device. So my CD/DVD device is a virtual CD/DVD reader that can be connected through this drop-down to either the physical CD/DVD reader on the host, or the CD/DVD reader on my desktop, or a media image on a data store that's visible to my ESXi host. It's very common to want to add additional devices, and there's some quick launch icons here to give me a second hard disk or an additional network adapter. And if you click this one here, what you get is a drop-down with a whole roster of additional devices that you can add to the hardware layer of your VM. So normally what I would do is I would walk through the roster of all the hardware, sizing it appropriately, configuring it appropriately according to the needs of my new virtual machine. So now that we have a good understanding of how you actually specify the virtual hardware layer of a virtual machine, what I'd like to do is go over all the components in more detail so that you more fully understand it. And of course, as I mentioned earlier, the foundation of all virtual machines is a virtual motherboard, which is to say software that faithfully emulates all of the onboard components of a typical motherboard. And it's based on a virtual chipset called the VMware virtual chipset, but also referred to as the BXDX-ZX virtual chipset. BXDX-ZX being a reference to legacy Intel chipset-based motherboards. And so every VM gets a PS2 style keyboard and mouse. Okay, they just get it right out of the box. You don't have to declare it. You can't make it go away. It's just there. You also get a video card, and your video card can be a 2D frame buffer video, or if you want, you can edit the VM's virtual hardware layer and select 3D. Okay, and select 3D. You also get a CD/DVD device connected to either an IDE controller for legacy Windows, basically Windows 7 and older, and similar vintage Linux machines or Linux operating systems, or SATA connected CD/DVD devices for essentially Windows 8, Windows Server 2008 R2, and everything newer. And the reason for that is because IDE basically reached end of life around the Windows 7 time, and it was replaced by SATA for CD/DVDs, for hard disks, and so on beyond Windows 7. Now, I can also get a floppy controller with up to 2 drives. And floppy controllers have rightfully gone the way of the dinosaur from a hardware perspective. So have floppy devices, but virtual floppy devices are still useful because drivers are typically shipped in FLP media image format. So drivers that you need to install when you install your guest OS, or drivers that you need after the fact typically come in FLP format. So in order to activate them, what you would need to do is define one floppy controller, at least one floppy drive, and then edit the virtual floppy settings and point it at the floppy media image supplied by your driver vendor. Okay, IDE is for legacy operating systems, Windows 7 and older. SATA is for everything newer than Windows 7, and SATA is much more flexible and can support many more devices. Now, another thing you should be aware of is that I can actually declare IDE connected or SATA connected virtual disks. And the reason for that is because some legacy operating systems like DOS don't understand or support SCSI very well. And so if I have to run one of those legacy operating systems, I may have to declare both an IDE CD-DVD reader and an IDE hard disk, likewise with SCSI. The default video is 2D, but if I want, I can promote it to 3D. And 3D is now supported in most modern guest OSs, both desktop OSs and server OSs. Now let's take a look at the hardware components of our virtual machine in more detail. My virtual machine declares a certain number of sockets and cores. A socket is essentially a virtual processor package that I put into a receptacle on the virtual motherboard. It works very much like a physical processor going into a physical socket. Now the point here is my virtual motherboards have the potential to accept many virtual processors, so they're essentially multi-socket motherboards. And when I declare the socket and core layout, what happens is when the VM powers on, the BIOS or UEFI will simply report the declared vCPU socket and core layout to the guest OS, and the guest OS will just automatically believe that's all the CPU resources there are in the machine. Now, the VM is scheduled to run by the VM kernel after you power it on, and after you power it on, the VM kernel needs to supply physical CPU resources, either a physical core or a hyper-threaded or symmetric multi-threaded logical processor to each virtual core in the VM. Now, VMs see a somewhat simplified socket and core layout. The default socket and core layout for most operating systems is single socket, single core. This is just VMware's way of saying don't waste CPU, don't declare more than you need. But it's up to you to set the socket and core layout to anything that works for you. I can have literally, this is where VMware maxes out, 768 virtual CPU cores across one or more sockets. And you heard me right, you can declare all those cores on a single virtual CPU socket. And there's no limit on or no practical limit on the number of sockets you can declare. Now, VMware has a hard limit of a total of 768 cores spread evenly across all sockets. But you'll never hit that because you'd have to have a machine with at least this many cores and logical processors to hand out in order to be able to build a VM that big. The effective limit is how many cores do you have on your ESXi host? Okay. Now, if you power on a VM, put it in service, and then later on decide you need to change the CPU settings, either up or down, it's really easy. You just power off the VM, edit the CPU settings, change the socket and core layout to whatever you need now, based on your actual CPU needs, and then power your VM back on. All modern operating systems will detect the changes and automatically adjust to them. Let's talk about physical CPUs and virtual CPUs. The virtual CPU socket and core layout is completely independent of the physical socket and core layout. Now, each virtual CPU core will report exactly the same make, model, family, and stepping as reported by the physical CPUs in your PC server. But at the VM level, the virtual socket and core layout typically does not match the physical host socket and core layout. There's no reason to, unless you had the unique situation of requiring a host to run just one VM with every last available CPU resource the host has. Now, one of the things you should be aware of is virtual CPUs do not get hyper-threaded, which is Intel, or symmetric multi-threaded, which is AMD logical processors. Hyper-threaded and symmetric multi-threaded logical processors are held by the VM kernel and used to run low-priority VMs. In other words, they're not very powerful, so the VM kernel uses logical processors to run VMs with either low share value or VMs with no useful work to do, or VMs who are using CPU lightly. Virtual CPU sockets can have more cores than the physical CPUs in your machine. So if I had an entry-level server, the physical CPU layout might be 2-socket quad-core, but I could declare a VM that's single-socket 6-core, and that works just fine. So the cores that are used to power the CPUs in a VM can come from multiple physical processors. And there's typically no performance difference when declaring the same number of cores across more or fewer sockets. So what that means is that a 6-socket single-core vCPU declaration should deliver just as much CPU to a VM as if I changed the declaration from 1 socket 6 cores. So all that really matters is what's the total core count. It doesn't matter how many sockets they're spread across, it's just what's the total core count. And it's easy to customize. So here we're at the customize settings step. We're looking at virtual hardware. We expand CPU by clicking on what was a right-facing triangle, and it will rotate horizontal, and it will expand the sub-properties of the particular hardware device, in this case CPU. And I can see right here that, let's just zoom in, I can see that my CPU has a single core on a single socket. Rather than typing in numbers here, I have drop downs. And with the drop down, what I do is I change the number of sockets, and then I change the number of cores per socket. If I have a multi-socket virtual motherboard, then every virtual CPU, that is processor package, that I declare must have the same number of cores. So if I have single socket 6-core and I promote it to 2 sockets, I have 2-socket 6-core per socket for a total of 12 cores. Good. And there are other CPU properties like hot plug that I will talk about in a future course. There's some things to be aware of. Windows desktop OSs have a 2-socket limit. So Windows 8, 8.1, 10. You can't declare more than 2 sockets. There's actually a high-end version of Windows 10 desktop. It's actually Windows 10 Workstation, and it can have a total of 4 sockets. So that's a desktop consideration. A server consideration is, depending on the version of Windows Server you're installing, some versions of Windows Server licensed by the CPU. The only currently supported Windows Server version that's licensed by the CPU is Windows Server 2012. 2016, 2019, 2022 are all licensed by the core. But here's something you must keep in mind. The total core count inside your VM across all declared sockets and cores must be less than or equal to the total ESXi host core count. So if I have a 16-core ESXi host, so maybe it's 2 sockets, 8 cores, the largest VM I should create is 16 cores. Why? Because in order for a VM to power on, all virtual cores must be serviced by physical cores. If I declare a VM that's bigger than the physical core count on my ESXi host, that VM may not be able to power on because there may not be enough cores and or hyper-threaded logical processors to service all of the declared virtual CPU cores. And there's a basic rule in VMware that says if at the virtual hardware layer, the VM kernel, the core OS component of ESXi, cannot service all of the VM's virtual hardware at power on time, the VM simply will refuse to power on. How do you fix that? You notice that the VM's declared to be really big, you edit its settings, you dial down the CPU to something that the host can actually do, you save the settings, you power on your VM, and it'll go. Now, what about memory? Well, virtual machines get virtual memory. Your physical server has physical memory, virtual machines get virtual memory. First of all, what you do is you declare how much RAM you want the VM to think it has. And you just edit a setting to do that, and when you power on the VM's BIOS or UEFI will report whatever you type in the memory box to be the maximum memory available to that operating system. It has to be a multiple of 4 megs. 4 megs is the absolute minimum, and yes, DOS would run quite well in 4 megs. 24 terabytes is the absolute maximum that you can declare, but the actual practical limit is the size of RAM on your ESXi host. And you see, the problem is if I have an ESXi host with 128 gigs of RAM and I declare a VM with 192 gigs of RAM, the VM can actually power on because the VM kernel will deliver memory to the VM in pages. But because the VM could demand more memory than the host has, the VM kernel would have no choice but to make up the difference through virtual memory, which means taking pages away from the VM and putting them on disk to make room for pages the VM needs, and fetching those pages off disk and bringing them into memory. So what I get is VM memory going from the physical host to disk to make room for memory that needs to go from disk back to the host. That's called paging. And if you have a VM that's doing a lot of paging, then you're going to have significant performance problems because storage is many orders of magnitude slower than high-speed memory. The other thing I have is storage. My VMs need some kind of storage. I refer to it generically as disk, but basically a virtual disk to a VM is just a file on a data store. Now, to present compatible virtual hardware to the guest OS, the storage subsystem of a VM consists of a storage controller connected to one or more virtual disks. And to be more accurate, I can have up to 4 storage controllers connected to up to 64 vDisks per controller with up to 62 teras per vDisk. Now there are 3 different controllers I can pick. The first 2 are virtual SCSI controllers that emulate physical hardware devices. BusLogic was a maker of SCSI host bus adapters that was bought out in 2003 by LSI Logic. So if you're going to run Windows XP or Windows Server 2000, you might have to declare BusLogic. LSI Logic is an ongoing maker of SCSI host bus adapters, and they provide modern competent storage controllers for physical servers. And I could pick either BusLogic or LSI Logic for essentially legacy Windows, BusLogic, or modern Windows, LSI Logic, and likewise legacy Linux, BusLogic, or modern Linux, LSI Logic. Now VMware has a better choice, the VMware Paravirtual Controller. This is a virtual SCSI host bus adapter that has no physical counterpart, and VMware engineers designed it to be simple, efficient, and capable of doing IOs at the highest possible rate. So what I need is a virtual SCSI controller and then one or more virtual SCSI disks. A virtual SCSI disk is presented to the VM as a disk device of a declared size. And it can be either pre-allocated to full size, that's called thick disk, or it can be declared to have a size, but grows dynamically as more programs and data are written to the disk, up to but not beyond its declared size. Thin disk is more space efficient. The virtual disk name typically matches the VM name with some number to indicate that it's disk 1, disk 2, disk 3, and so on. And when I make a new vDisk, I have to say which data store, which is a storage volume, and directory the vDisk lives in. By default, it lives where the VM lives. And I have to specify something called the disk node. The disk node is the hardware address of the storage volume on the storage subsystem. So the default node is 00, which means it's off the first SCSI controller, and it's the first device or target on that SCSI controller's storage bus. The other thing I have is something called a disk mode. A mode is the ability to handle snapshots. So first of all, I'll talk about snapshots more a little later on in the follow-up course, but the disk mode in a nutshell says, is it okay to do snapshots, yes or no? By default, the answer is yes. Okay. The second thing it allows me to do is change the default to a setting called independent, which means that the vDisk runs independent of my ability to do ad hoc snapshots. That means you just can't. And it can be independent persistent, which means data written to the disk is persistent. It can't be undone or backed out. And non-persistent says data written to the disk is actually written to a snapshot volume, and when you either power down or reboot the virtual machine, all the changed data is discarded and the VM goes back to the original state, the state the VM was in disk-wise when the snapshot was taken. I'll have more to say about snapshots later on. So I mentioned in the previous slide that the VMware Paravirtual Controller is now quite often the default for new virtual machines. And the reason for that is because it is a low overhead, high throughput virtual SCSI host bus adapter that has broad guest OS compatibility. It is the best choice for a VM's virtual SCSI host bus adapter. And the reason for that is primarily speed. It can be either a boot controller or a secondary controller for Windows or Linux or any other supported guest OS. If you're installing Windows, desktop or server doesn't matter, you have to add the Paravirtual SCSI driver during install time. So what will happen is Windows will basically just come up and say, hey, I can't find a driver for the storage controller, provide one. And in the next video, I'll show you how you can connect VMware supplied PV-SCSI driver to your new virtual machine so that the installer can pull in the driver, add it to Windows, initialize the storage controller, and continue on with the install. If you're installing Linux, it's even easier because most Linux distributions ship with a PV-SCSI driver included. So Linux will just identify the PV-SCSI controller, select the correct driver, and the install will just continue. Now, PV-SCSI is faster than LSI logic controllers, but only by a little bit, a few percentage points. So if you need physical hardware compatibility, because maybe you're building a Windows VM that's going to be part of a Microsoft failover cluster configuration, picking LSI logic will not typically result in a noticeable reduction in speed. And you need the compatibility. You should never pick bus logic unless you have no choice. Bus logic controllers are very slow and they are not scalable. So you will notice a significant performance reduction if you pick bus logic over LSI logic or PV-SCSI. The only use case for bus logic is if you're installing Win2K3 or older, which would include Windows Server 2000 or Windows XP, and it's the only compatible storage controller. And even then, I would try PV-SCSI first. PV-SCSI is literally 3 times faster than a virtual IDE or SATA controller and virtual disk. IDE and SATA are high overhead, low throughput interfaces relative to SCSI, so you should only choose SATA or IDE based virtual disks if your operating system simply can't do SCSI. Now, what about other devices? Well, one category is removable media devices. I can have up to 4 IDE, CD-DVD, or HDD devices. And again, IDE was appropriate for Windows 7 and older, and Linux is of the same vintage and older. SATA is appropriate for Windows 8, Windows Server 2008 R2, and newer. And I can have up to 30 virtual SATA devices, but realistically, there's only so many CD-DVD readers I'm going to need. And again, yes, I can do virtual hard disks or storage volumes, but be wary of performance hits to virtual disks that are connected to IDE or SATA controllers. And I can have up to 2 floppy devices. And again, the only use case now for floppies is so that I can access media images of drivers in FLP format. So removable media connections. What this means is if I have a removable media device like a virtual CD-DVD or a virtual floppy, what can I connect it to? I can connect it to media in the physical server CD-DVD reader or floppy. I can connect it to media in the local desktop CD-DVD reader or floppy. Or, and this is the most likely case, I can connect it directly to a media image. A media image is a file made up of essentially all the data on a CD-DVD or floppy physical media. A CD-DVD file is called an ISO file, and a floppy media image is called a .flp file. And again, the most likely use case for this is drivers for devices. Virtual removable media can be either connected, in which case the device reports that there's media in the virtual tray and allows the guest OS access to it, or it can be disconnected, which means that when queried, the device will just simply say, nope, the removable media tray is empty. Now what happens is operating systems will occasionally spin the CD, DVD, or floppy just to see if there's any media in there. And if you have the virtual media set as disconnected, the device will not even bother with the actual media image. It'll just immediately report back to the guest OS that the removable media tray is empty. So I can now complete my virtual machine. I can add any needed virtual NICs, USB controllers, and so on. So virtual NICs are virtual network adapters. I can have up to 10 virtual NICs at the hardware layer of my VM. And like storage controllers, there are 3 different choices for virtual NICs. There is the best choice in most cases, which is VMXnet 3. This is a virtual network adapter that has no physical counterpart, and what distinguishes it is highest speed, lowest overhead, simple driver interfaces made available to all supported guest OSs. So you should use VMXnet 3 for your virtual NICs in about 99.9% of all cases. The only reason to use legacy physical NICs, that is, virtual hardware that emulates legacy physical NICs, is because you have a use case that specifically calls for, I need either an Intel EtherPro 1000 1GbE NIC or an Intel EtherPro 1000E 1GbE NIC. So some network security software that does intrusion detection or network security or that sort of thing, some of that software gets very intimate with the NIC and consequently will only work with specific makes and models of NICs. And Intel EtherPro 1000s, which are legacy NICs for Win2K8 and older, or Intel EtherPro 1000E, which are more modern NICs supported in Windows Server 2012 and newer, will work at the guest OS level. These virtual NICs present hardware that is indistinguishable from real physical Intel hardware, and so that network security software will see the virtual NIC, bind to it, and work as expected. But as I said, this is a very limited use case. If all you want to do is send and receive network packets as quickly and efficiently as possible, which is mostly what we need to do, always pick VMXnet 3. Regardless of the NIC I pick, I have to connect it to the correct port group. A port group is a named set of ports on a vSwitch, and I would create different port groups so that I can connect to different LAN segments, such as production, storage, backup, whatever it is I've set up in my environment. The idea here is I'm going to want my VM to network with its peer machines, so other VMs, other physical machines. So I need to have a connection through a port group to a vSwitch, through uplinks to the physical network so that I can get to all my peers. Now I can also add a USB controller, and in some cases I'll get this by default. If I have a USB controller, then through VMware's client interfaces, the remote console and so on, I can connect any host or desktop USB devices through the user interface to the VM and have local devices or server devices be presented to the VM as if they were directly connected to the VM. So this means that a VM can use any USB device. That means USB printers, soft VoIP phones, keyboards, mice, anything that's USB. Some devices will just be automatically recognized. So, for example, flash thumb drives can be plugged into your notebook and then pass through to the hardware layer of your VM, and then your VM can start doing IOs to your local flash thumb drive. You don't need drivers for that. But if I have a soft phone, if I have, say, a USB printer and I want to present it directly to a VM, then it is likely I'm going to have to install drivers in the guest OS so that it can actually interact with the USB device. So we've just finished a complete discussion on how to create the virtual hardware layer of a new VM. And we talked about which devices are the best ones to pick, typically VMXnet 3 for network adapters and VMware Paravirtual for virtual SCSI controllers. And this is so that we can maximize the I/O throughput for our networking and storage. We've talked about the importance of sizing VMs correctly for compute resources, CPU and memory, and we've discussed many other things. Now what I want to do is follow up with a hands-on lab demo where I'm going to log directly into an ESXi 7.0 host. We are going to build a new virtual machine, and we're just going to go through building the virtual hardware layer and making adjustments. We are going to size the virtual hardware according to the needs of our VM, and I'm going to show you how to configure virtual CD/DVD devices to point at media images so that when we power on our new virtual machine, it will launch the Windows 10 installer. A virtual machine is a 100% software object, starting with the virtual hardware layer. Virtual hardware is software that faithfully behaves like generic PC server hardware. And because it's software, it's very easy to adjust virtual hardware. You can add devices, remove devices, configure devices, scale up devices, compute resources, and so on. Now, virtual hardware simply hands off I/O events to the VM kernel, and the VM kernel completes the I/O event for the virtual machine, the VM kernel sending the I/O event to the appropriate underlying physical hardware. Virtual machines have broad guest OS support. They support Windows going back more than 20 years. They support business editions of Linux and other operating systems that were published for Intel and AMD CPUs, like Solaris for x86, the BSD family of operating systems, Apple's OS X, SCO's, Unix's, and so on. Now, in order to get your virtual hardware perfect, you should focus on right-sizing it according to your VM's needs. That means just as much CPU as it needs under peak load and no more, just as much memory as it needs under peak load and no more, and vDisks that are sized appropriately to the storage needs of your VMs. So that's my video on how to build the virtual hardware layer of an ESXi 7 virtual machine. I'm your instructor, Larry Karnes. I hope you enjoyed, and enjoy the hands-on lab demo that follows. Okay, now it's time for a lab demo where we are going to build the hardware layer of a virtual machine. My starting point is a Windows Server 2012 machine. This machine is connected to the same network as my ESXi host, and ESXi hosts are managed through a web-based interface called Host Client. So to get to that interface, I'm going to launch Chrome. Now you'll notice I also have Firefox on the browser bar. And Firefox mostly works, but there's a challenge. And the challenge is this. VMware develops their software to be compatible with Chrome because Chrome has just a huge percentage of market share. I think it's up around 65, if not higher, % market share. Firefox has a much smaller market share, and it's HTML5 compliant, but there are some little nuances between how Chrome renders and how Firefox renders. Microsoft Edge, now that it's based on Chromium, should render in a manner that's true to Chrome. So you should have an equally good experience with Edge. But Firefox in the past has had some minor compatibility issues, so when I work with vSphere, both ESXi and vCenter, I typically go to Chrome. So my ESXi host is esx2.esxlab.com. I am just going to hit enter. That brings me to a web-based login prompt. I'm going to log in as root with root's password. And here we are. This is a web interface that is used for standalone host management. And I'm going to get rid of the welcome link. So you'll notice I have a navigation bar. Now your navigation bar might look like this, collapsed, or you can just click it again and it expands. So I'm going to go to virtual machines, and you'll see I have no virtual machines. So what do? I click on Create Register Virtual Machine. And what this does is it brings up the new virtual machine dialog, and you'll notice I have three options. I can create a new virtual machine. I can deploy a virtual machine from an OVF or OVA. This is basically a vendor-neutral way of distilling a virtual machine down to its core components and exporting it to your desktop in a way that's safe for file transfers over the internet onto flash drives and so on. Or if I want to take ownership of a virtual machine, I can just register. But our task is to make a new virtual machine, so we'll just go to the next step. In the new virtual machine wizard, I have to give the virtual machine a name. So I'm going to call it Windows 10 Test. I tend to name my VMs Test if I know I don't want to keep them for very long. I mentioned compatibility in the lecture. VMware introduces new virtual hardware versions, typically with new versions of ESXi, and sometimes with Workstation, as you'll see with version 12 and version 15. what I would want to do here is pick the version of ESXi that's the oldest version still in production in my environment. So if I had some ESXi 6.5 hosts, I would pick that. If I had early 6.7 hosts, I would pick that. But in my case, this is a lab environment, and the only ESXi host that I have in my lab environment runs ESXi 7.0. And you always want to get the newest version available so that you can take advantage of the latest available virtual hardware for scalability, for performance, for access to new hardware features, and so on. So I'm going to pick ESXi 7.0 virtual machine. The next thing I need to do is I need to set the guest OS family. And you'll notice that there's Linux, there's Mac, there's Windows, and then there's literally everybody else. Linux, Mac, and Windows are pretty self-explanatory. If I pick Other, I can see all sorts of different operating systems that VMware supports, including FreeBSD and Novell NetWare and Solaris and SCO and even ESXi. So you can build a VM in a VM. It's very cool. But let's get to the point. We want to actually install Windows. So we'll pick Windows, and then we will pick Windows 10 64-bit because that's the OS we're going to install. Now that I've set the hardware compatibility, I want it to be compatible with ESXi 7 virtual machine virtual hardware, the OS family, and the actual OS I intend to install. I can move on to the next step. Now the next step says, let's take a look at storage and pick a data store that will host the on-disk footprint of my new virtual machine. You have to be really careful here because some of these data stores, this NFS data store here, and this NFS data store here, are actually read-only data stores, which is to say I can read content off of them, but I can't write to them. And the wizard doesn't tell you, you just have to know based on your environment. I do have two data stores that I can use where I have read-write access, and that's ESXi 2 data store 1 or production. So I'm just going to pick ESXi 2 data store 1. That's the local data store for my ESXi host. So we move to the next step, and what I get is a default virtual hardware inventory that is sized appropriate for the guest OS that I declared in step 2. Now this is just default sizing. I can change any of this as I see fit. So for example, if I want, I can have up to 4 cores because my ESXi host has only 4 cores, and I can't declare more virtual cores than my host has physical cores, or else my VM won't be able to power on. And as far as memory goes, I don't really need 4096 megabytes. That's 4 gigs. I can say 2048. 2 gigs is enough because we're not going to do much with this VM. I just want to show you how to get it going. I have a hard disk, and it says, well, I'd like it to be 48 gigabytes. And to be honest, I can make it as big or as small as I like. Again, because I'm not going to do much with it, I will change the size. Let's make it 64 gigs. But there's something you need to be aware of. With virtual hardware, especially virtual disks, there's provisioning. So I can set the disk provisioning to either thick, lazy 0, thick, eager 0, or thin. Thin means whatever I declared the size to be, that's the maximum size of the vDisk, but only allocate space in 1 meg chunks as the vDisk needs to grow to hold more programs and data. Thick disk says, go grab all 64 gigs now. And lazy 0 says, but don't fill the disk blocks with zeros until they're first used. And thick disk eager 0 says, grab all space declared now and fill the disk with zeros now, which would mean I would have to write 64 gigabytes of zeros to that file. I don't want to wait for that. And I don't want to grab space that I may not need for months to years from now. So I'm just going to thin provision. There are other settings that I can look at under disks, but for the most part, this will do the job. Here's the SCSI controller. In the lecture, I talked about the pros and cons of the SCSI controllers, and what I said is the fastest SCSI controller is the VMware Paravirtual controller. This controller has highest throughput, lowest overhead, simplest driver interface, which is all the good news. The bad news is that Windows Install Media does not include a driver for the VMware Paravirtual SCSI controller, which is actually not a real problem because VMware makes their own drivers available, and you can just install the driver at OS install time, which will bring the driver into Windows, activate the driver, give Windows access to the storage devices so that Windows can partition, format, and install onto the storage device behind the VMware Paravirtual controller. I have a SATA controller here, and I also have a USB 3.1 controller. Now with USB 3.1, I could do USB 2. If I don't want my VM users to be able to connect USB devices, I can just simply delete the USB device. I'm going to do that now. As far as the network adapter goes, I want to expand this because there's a couple of things I want to do. I want to pick the right port group. So internal is my test network, and production is a network where my VM can talk to other VMs, so I'm going to pick the production port group. Connected power on says when the VM's virtual hardware is initialized, automatically connect the vNIC to the vSwitch so that when the VM comes up, it'll see that the NIC has a link to the switch. In the lecture, I talked about the different adapter types, and I said EtherPro 1000 is a legacy adapter, and it was adequate for Windows Server 2003 and older. EtherPro 1000E is a newer physical adapter, and it was first supported by Windows and Windows Server 2012. But the virtual network adapter that has highest throughput and lowest overhead is VMXNet3. Now this is another cool thing. It says MAC address. ESXi will automatically generate a MAC address once the virtual hardware is created. Or if I want, I can go to Manual and manually specify any MAC address I want here, which is great if I'm migrating a workload from a physical machine to a virtual machine, and I want the virtual machine to have exactly the same MAC address as the old physical machine. But I'm going to go back to automatic because I don't need that feature. Now the next thing I need to do is I need to connect the CD/DVD reader to the Windows 10 install media. Instead of host device, I'm going to go to Data Store ISO. An ISO is a file of all the contents of a CD/DVD physical media image. So I'm going to say Data Store ISO. I'm going to go to a data store where I downloaded Windows 10 install media. Here it is, right here. So all I need to do is pick it and then say select. And I can verify that everything's good because it says the NFS ISO's data store followed by the full name of the media image. It's connected to a SATA controller and it is set to connect, which means it will connect at power on. As far as the video card goes, I didn't actually mention or show you how to do this in the lecture, but what I can do if I want is let's do custom settings. I can enable 3D. This allows my VM to run 3D accelerated applications. Now the 3D renderer is best set to automatic. That says if there's a GPU in your server and it's properly configured, use the GPU. Otherwise, use the host CPU to perform 3D rendering functions. And as far as 3D memory goes, I'm going to up it to 1024 megabytes. And I don't have any security devices, so there's nothing more I need to do there. Now it's always a good idea to do a second pass through all of your hardware to make sure that everything is sized appropriate. If I want, I can add another hard disk. I can add another network adapter. Or I can click this drop down and I can pick any one of these devices to add to the virtual hardware layer of my VM. But I'm satisfied with what I have. So let's go on to the next step. In Ready to Complete, it will tell me everything that I've selected. 2 vCPU cores, 2 gigs of RAM, 1 network adapter connected to the production port group. The network adapter is a VMXNet3. I have an IDE controller. I have a SCSI controller. It's the VMware Paravirtual. I also have a new SATA controller. I have a hard disk of 64 gigs. It's thin provisioned. I have a CD/DVD. I can see the data store and file it's connected to, and it's connected, meaning that when I power on the VM, everything will connect. So that's it. I've just built the hardware layer of a new virtual machine. And in a few seconds, what I'll see is the new VM appears in my virtual machines roster. And if I click on it, then I get a summary of the new virtual machine. If I want, I can go back and edit. And one of the things that you want to do with a virtual machine is go to Options, go to VMware Tools, and scroll down and make sure that time synchronization is checked. This says synchronize the VM time to the host clock. Since the host clock should be configured to use NTP, Network Time Protocol, the host clock will always be accurate, and by time syncing, the VM clock will always be accurate. The other thing I like to do is go to Boot Options, and because I don't need an extensible user interface or a UEFI, I'm going to switch to BIOS. You notice a warning saying, well, that might impact the installed guest OS. Not a concern because I don't have an installed guest OS. And the next thing I like to do is change the power on boot delay to, you notice the unit of measure is milliseconds here. So I'm going to change it to 10. 1, 2, 3, that's 10 seconds. This will give me a countdown timer of 10 seconds so that if I want to, I can either change the boot order and boot off a non-default device, or I can go into the BIOS. Speaking of BIOS, I can go into setup if I want. If I have an issue and I fail to boot properly, then it can retry rebooting and so on and so on. There's obviously much more here to see, but this is good enough for now. So I'm going to save that to apply my changes. And the next thing I need to do is I need to open a console. So I'll go to Actions, Console, and I'll launch the remote console. And it says, hey, you want to open the VMware remote console, and we have an application for that. So we always want to use VMRC links and associate them with the VMware remote console. So we're going to accept this and say yes. This is the VMware remote console application. And what it does is it makes a secure connection to the ESXi host that the VM is currently residing on. And then it shows the console. In this case, the console is pitch black because the virtual machine is powered off. So I'm going to move the virtual machine's console up to the top, and I'm going to power on the VM. And remember, this VM's never been powered on before. It has no OS installed, so let's see what happens. So here's my countdown timer, and here's the BIOS. You can see the countdown timer here. If I want, I can click in the console, hit escape, and then pick a non-default boot device. And so what happens is, because I've connected the Windows 10 install media, it'll try to boot off the hard disk. That'll fail. And then it'll go to the CD/DVD reader, which is what it's doing right now, and it's pulling in the installer for Windows 10. And so you can see that the installer has been passed control. The installer has started. We have to wait a few seconds for the installer to get pulled into the new virtual machine. And the installer initializes, and here we go. We are now ready to install Windows 10. Now I'm going to stop here. And the reason I'm going to stop here is because I'm going to do a follow-up video to show you how to install Windows 10 into a virtual machine. And so I'm going to give you the lecture for that, and then I'll take you through another hands-on lab demo to show you exactly how it's done. But for now, that's how you build the virtual hardware layer of a VM, along with key settings like time synchronization and boot delays and so on, to make sure that your VM has accurate clock time and boots in a way that allows you to interrupt the boot process and, when you need to, boot off of any device. Well, we've made it to the end of the tutorial, and as a special thank you for getting this far, I've got two things to offer. First, an absolutely free ebook. This ebook includes all the slides and slide notes, and it also includes detailed lab steps so that you can build a virtual machine from scratch and take it all the way through from the vHardware layer to installing and testing out the guest OS. And you can download it via this bit.ly link. Bit.ly links aren't going to work in the video, so also look at the notes underneath this video and I'll post the links there. And as a special offer to people who follow us on YouTube, you can get 90% off our full VMware vSphere 7 with ESXi and vCenter course book set. This course book set normally sells for $199.95 US, and you can get it for just $19.95 US. And again, I'll post the full link to it in the notes underneath the video. I'm your instructor, Larry Karnas. I hope you enjoyed this video tutorial on VMware vSphere 7 virtual hardware. Hope to see you in a video in the very near future. Thanks again.